Welcome to another video on finding maxes and mins of functions. In this video we are going to be looking at the first derivative test. So this is a test that we can use to tell whether a function has a max or a min by looking at the sign of the derivative. So let's look at what it says here. It says if f prime of x is greater than 0 to the left of c and f prime of x is less than 0 to the right. So maybe here's our value of c. So we are greater than 0 to the left and less than 0 to the right. This is the sign of our f prime. Then our f, this would mean our f is going up and our f is going down. So our f is going to have a relative maximum. Same idea, here we have c. We're looking at f prime. If f prime of x is less than 0 to the left, so we're negative over here, and greater than 0 to the right, then the shape of our original f is going to be going down and then going back up. So this would be a min. This was a max. And then the last thing the first derivative test tells us is if on either side of c our f prime has the same sign, maybe it's negative and negative, then our original function would be going down and going down some more. So that would mean not a max or a min. And if they're both positive, then that would mean they're both going up. So again, not a max, not a min. So we have three situations here. On the left it's positive, right it's negative, then it's max. Left it's negative, right it's positive, then we have a min, same sign, then it's not a max and it's not a min. So we're going to be looking at some functions here where we are given a graph instead of, say, an equation. We're given a graph of the derivative function, and what we have to do is we have to figure out where are the stationary and singular points of our original function f. So we have to find the x-coordinates. We can't find the y-coordinates, just the x-coordinates. And then we have to decide, okay, is this a relative max, a relative min, or maybe it's neither. And the way we're going to do this is by using that first derivative test. So remember, the stationary points occur where this f prime of x equals 0. So we are thinking of the graph that we have here. These are our y values. The y values are the f prime. So if we're looking for where our y values are 0, we're looking for where our function touches or crosses that x-axis. This is an example of where we have derivative function is 0. So we can see here this happens at x equals 2. So we found the x value. Now we just need to classify it. Is this a max? Is it a min? Or maybe it's neither. So what we're going to do is we're going to use that first derivative test. So over here to the left of 2, our y values are down here. That's negative. To the right of 2, our y values are up here. That's positive. So that means our original function was going down and then it's going back up. So this is a minimum. Okay, singular points. This is where our derivative does not exist. And we can see that our derivative is this nice line. We don't have anything funny going on. It looks like it's always defined. So we don't have any singular points. Let's look at another example. So here we have another function. Once again, we are going to be looking for our stationary points first. These are where our derivative equals 0, so we're looking for where the y value of this function equals 0, and that occurs right here and right here. We have two spots. So this one is x equals 3, and this one is x equals -2. Okay, so we've figured out the x values. Now we just need to classify them. So if we think about what's going on here at -2, to the left of -2, we're over here. So our y values are positive. To the right of -2, our y values are negative. So that means our original function f, this is f prime, the original function f is going up, it's leveling out, and then it's coming back down. So that looks like it is a maximum. Let's look at x equals 3. So we're looking at the sign of f prime. So to the left of 3, we're here. That's a negative y value. To the right of 3, we're over here. Another negative y value. So our original f is going to be going down, levels out, goes down some more. So that is neither a max nor a min. Now, singular points. These are where our derivative is undefined. And it looks to me like we have a nice smooth curve here, and we don't have any places where it's undefined. So we don't have any singular points. Let's look at one more example. Okay, let's go through this the same way we did before. Stationary points first. So we're looking for where our derivative is 0. This is our derivative function, so we're looking for where the y values are 0. So it looks like we have a y value there of 0. We have another one here. We have a 0. And we have one more over here that is 0. So let's write those three down. Let's see, this is x equals 1, 2, 3. This purple one is x equals -1. And the red one is x equals -4. Now let's go through and classify them. So for the red one, I'm going to do that over here. So this is -4. We're looking at the sign of f prime, and then we're going to project back to the shape of f. So to the left of -4, we are down here, and that's a negative y value. To the right, we're up here, that's a positive y value. So our original f is going to be going down, levels out, and then goes back up. So this is a min. So let's look at the purple one. So this is -1. So we're looking at the sign of f prime, and then we're projecting back to the shape of f. So to the left, we are up here. That's a positive y value. To the right, we're down here. That's a negative y value. So my original f is going to be going up, levels out, goes back down, and so that is a maximum. Finally, let's look at our green one. So here, this is at x equals 3. We're going to be looking at the sign of f prime and then projecting back to the shape of f. So to the left of 3, we're here. We have a positive y value. To the right of 3, again, we have a positive y value. So our function's going up, levels out, goes up some more. So this is neither a max nor a min. Okay, now let's look at the singular points. This is our first one that has a singular point. And you can see at right here we have, right here we have that vertical asymptote. Our derivative function is not defined there. So that is at x equals 1. So we have a singular point at x equals 1. Let's see, using that same technique, if this is going to be a max or a min. So I have my same little picture drawn here. So to the left of 1, we're over here, to the left of 1, we're way down here on this part of our function. So those are negative y values. To the right of 1, we're up here, those are positive y values. So this means our original f is going down and then it's going back up. So that is a minimum. So that's what you do if you're given the graph of the derivative function and you have to try to figure out what's going on with the original function f.